Hey everybody, good evening from RV Falcor 2. I'd like to welcome you all to yet another dive stream. I see we have some viewers trickling in this evening. Right now it's about a little after 6:30 p.m. ship time. We just had our dinner. We've had an amazing day for outreach, which I'm sure Seb will tell you about in just a second. And we are once again back down on the seafloor, this time within the central Chaiten Delta, to be collecting a couple more geological samples with our fiber core instrument, which you will see once this sediment clears up a little bit. Hello, hello. See you all waving in the chat. As I was saying, we are back doing some more geological sampling, but we're going to have some time and space for biological sampling as well. We have some scoop bags attached to our ROV as well, which you'll be seeing, as well as some push cores. Sometimes we get some fauna in there as well. So super exciting stuff happening here. With me in the front row of the mission control room, I've got Zach and Joel as our pilots. And I've also got John Fulmer behind me. Also have Vite behind me, but he's been in and out. He's going to cover for me in a couple of minutes. And we've got an entire room of scientists as well, as always. It's a bit quiet today. I think everyone's a little tired. But we're excited to do some more sampling and excited to also answer all of your questions. Please pop them into the chat over on YouTube, Facebook, and Twitch. And our very enthusiastic team of scientists are happy to help out. Cool. And with that said, I'm going to pass it over to our watch lead for the next few hours, Dr. Sebastian Watt, the chief scientist for this expedition. All right, take it away.
Great, many thanks, Sophia. And it's great to have you joining us again today. Weren't sure if we could fit in an ROV dive today. I think it'll be a relatively short one, but I'm hopeful that we'll get some interesting samples. Now, as you can see, it's pretty murky water that we've got here at the minute, and not much of a view. That's not unexpected because this is our shallowest dive so far. Well, I think probably the shallowest one will do, to be honest, because we are right on the slope offshore the Chaiten Delta at about 80 meters water depth. And what we found, we did a couple of grab samples here last night actually, and we found that there was mud coming up in that, which was not particularly what we expected, but we think there's a sort of mud cover on the deeper materials, so this is where the vibrocorer will hopefully allow us to get through that mud and into the units beneath, which we've imaged with our geophysical data. We're expecting them to be coarser-grained units beneath the surface. But I expect there's quite a lot of sediment coming off these river systems that even in the 16 years since the Chaiten volcanic eruption have built up a layer of fine mud on top of the sediments deposited after the eruption. So we'll have to see if we can get down into those. It's a little uncertain how thick this mud is, and currently it's obscuring things a lot because of the landing of the ROV in this what is likely very soft mud. So we're just still waiting for that to clear a little bit, but as Sophia's just said, we had an amazing day today. We welcomed groups from several schools in the region. I think around 10 schools. Does anyone remember the number? It's around 10 schools in 4 groups. So 16 schools represented. 16 schools, yeah. So coming in on board in 4 groups from Chaiten town, from the surrounding region around Chaiten, and also from several of the islands. So this has been a really important part of the work that we want to do in the region, and it's been great to have such a successful day. The groups were coming on, around 20 to 25 or so in each group, touring the ship, coming up to the bridge, seeing the labs, speaking to the scientists, and it was great to see the sort of the interest and enthusiasm, and to give that insight into marine science that is not something that these children are likely to have experienced before. And you could see the clear interest and indeed the sort of level of knowledge that the children had of their region, and actually of a lot of the science that we were doing. So it was really really great to interact with everyone who came aboard today, and it's been a really successful day. So we are just sort of fitting in this final dive at the end of that day. So as Sophia said, there's a lot of people who've been working all day, which has broken up our sort of usual shift pattern as well. So this will just likely be one short dive, and then we'll go into more overnight mapping. So for those who haven't perhaps been on these videos before, haven't been watching this, just as a reminder of what we're doing in this project, we're exploring the impacts of volcanic eruptions in the marine environment in southern Chile, and we're particularly using an eruption in 2008 which transformed the surrounding region to understand those impacts. So we're using this as a sort of exemplary event, which we know deposited huge volumes of sediment into the ocean, to understand how that material was dispersed, how those environments have recovered and responded to that input of volcanic material, and also as a route to understanding archives of these types of event in the deeper geological past. So we hope by an understanding of this event that we can also explore and understand where and how we can explore deeper geological records. And that's useful to allow us to understand volcano behaviour over 100 to 1,000 year timescales, which of course adds information as well that is relevant to understanding volcanic hazards in the region. So the reason for this dive on the delta front is to try to get samples of that sort of nearshore material, which will provide us with something that we can then try to trace beyond and see how that changes, how the nature of the sediment may change with distance, where it has been distributed, and to understand the recovery of the system. So we're having to wait a while to get this to clear. This is just a matter of sitting there, do you think? Because we could go ahead with the Niskins. It's pretty turbid anyway. But would you be happy to core in this? Or is it close to the limits of what you can actually see? We can't really see the seabed.
Very fine. Yeah, I think you can see the board. I think we could see enough to get one.
Yeah.
Because that's already loaded, so we could just watch that go in and out. Then as far as, I don't know if we'll be able to
Is
see
there
the
any way
rock.
of pulling the sediment through? Because that's, there's a fish there.
What do you mean?
With the thrusters.
Oh, that's what I'm doing.
You're already doing that.
Yeah, and I sat down as light as I possibly could. So
this is as good as it
it's
gets.
just fluke, you know.
Yeah.
But yeah, I've got all the
You've got all
downs
that's
and
already,
backs that I
it's
have.
already pulling it back. Okay. Okay. Well, let's try the Niskins.
Okay.
And then we've got those. So, guys, we're going to fire the two Niskins. It's it's clearly very turbid here. Right, sorry about that. We're just discussing next steps because this water's taking a long time to clear. Not unexpected, really, given the shallowness of this dive.
That's it, right?
Yeah. So those have been fired. Yeah. So let's try, given the lack of visibility, let's try with vibrator. See how that goes in. Interested to know if there's resistance that you hit.
We're gonna see.
Is it a 2 meter one? So I've got in the room today a number of students and postdoctoral scientists and other scientists here with us. I think we've heard from all of them actually. Sion, I don't know if we've heard from you actually. Have we? No, not yet. We'll save that for a later dive. But anyway, behind me, actually where the marine biologists are usually sitting, but Gianluca is just behind them, I've got Alistair and Keris, who are both volcanologists, and they're here today to talk a bit about their interests, their work. So I'll hand over to them. So I don't know who wants to speak first, but I'll let them decide that.
We'll both go at the same time.
Yeah, that sounds good. So I'm a volcanologist at the University of Edinburgh, and Keris is at the University of Birmingham.
Yeah.
So we both work on explosive volcanism and their impacts and hazards, but particularly from the geological side of things. So we work on deposits of volcanic ash, other volcanic products such as lavas. And we use this to try and reconstruct eruptive histories, the processes that have happened in those eruptions, and reconstruct the timing of these events as well. So this is really particularly of interest and significance for this expedition, because we're starting to recover quite a lot of volcanic material now. Hopefully we'll recover a lot more material and hopefully be very successful in this dive. And yeah, if we can fingerprint and match these to the volcanoes and the eruptions that these have come from, then this can give us an age as well for these eruptions, and also tell us a lot more about the processes, particularly in an area like the marine environment, which we don't really understand as much. Don't know if you want to add something.
Yeah, so although neither me or Alistair have specifically worked with Chaiten volcano before, we're trying to apply some of the experiences we've learnt in the past from our previous studies. So as you said, I'm based at the University of Birmingham, just finishing the last part of my PhD, where Alistair did his PhD.
Yep.
So I don't know if you want to talk a little bit through some of your research you've done in the past?
Yeah, that's fine. Yeah, so I guess my volcanological research started with a master's degree in the UK, which was working on Icelandic volcanism. I worked on some subglacial volcanoes and their products, and this was mostly lavas, effusive eruptions that produce lots of lava flows that were in contact with ice. So during these eruptions, there's a whole bunch of processes which are very similar to underwater volcanoes. As ice melts, you generate a lot of water, and that essentially you get very similar interactions between that magma and water. So we call it a magma-water interaction. Following that, I worked at the British Geological Survey for a bit, doing an internship there, and various other places around the world, doing field work in Italy, in the US, in the Philippines. But my PhD was based in Mexico, where I worked on cores that were collected from based in Mexico, from Mexico City. Within this part of within this region, we collected around 500 meters of core below the surface, and that contained around about 450 ash layers. So we had a lot of volcanoes to reconstruct. And from this we can try and reconstruct eruptive histories, the frequency of events that impact a particular region, and in that case it was Mexico City, which is one of the largest populations in the world. So sort of applying those sort of methods and the same approaches to these cores in this expedition. Karis?
Yeah, and so my current research is based around a volcano in Indonesia, so it's called Anak Krakatau. It's it's an island volcano between Sumatra and Java. Some of you may have heard of it before. In 2018 it collapsed. So when I say volcanic collapse, I'm talking about a really rapid landslide, but happening on a much bigger scale. And I'm sort of looking to investigate what happens to the magma chamber after you lose such a significant amount of volume. Unlike Alistair, I'm not working with cores, but I am working with tephra, so volcanic ash. We collect that in a way where we go out to the field and we essentially dig a hole and then we log the ash throughout it. But I'm combining this with sort of a volcanic history. So I go through a lot of archives, a lot of photos and a lot of old maps. And I do that to reconstruct what the volcano looked like through time. And we put together a really high resolution understanding of how it's erupting, what it looked like morphologically, and then what this means for what might be happening in the magma reservoir. So yeah, I'm just coming to the end of my research. I've got about 6 months left. But yeah, I've really enjoyed it, and I'm hoping to be able to apply a lot of the skills I've learned to what's happening here in Chaiten.
Yeah, and just brilliant. Just a note about what's happening on the screen as well for everybody watching at home or wherever you're watching. So what we're doing at the moment is we're pushing down the vibra core, which is this around about 2 meters of aluminium cylindrical tube, basically, which we're pushing into the ground. We're using vibrations to shake that into the ground, so it pushes sediment on the outside away from the core itself, but keeps all of the material intact in its stratigraphic or layering position on the inside. And just see that it was a little bit firmer than we expected. As Seb was mentioning, that we did some grab samples last night. We recovered a lot of muddy material, which is just a very superficial upper sort of half a metre or so.
Yeah, so hopefully with this slightly longer core barrel than we can get from grab sampling, we might be able to push through that really muddy surface layer and hopefully get some volcanic material. So we're right in the delta of Chaiten, so this is where the output of all these volcanic mud flows would have been flowing through, and this is the material we're really hoping to pick up here.
Yeah, exactly. So a bit more resistance is quite hopeful, but with the cores we can't really tell exactly what we've recovered until we bring them back onto the ship.
We have to be patient.
Yeah, exactly. So this is quite a long process. A lot of stuff happens when we bring the ROV back up. We start with taking off the cores, cleaning them up a little bit, and then starting to cut down and see where our sediment surface is, trying to not disturb any of the sediments in between. Once we've got these, we split them open, and then we have two halves. So we have two semicircle shapes and two D shapes of each half of the core, which one half we archive and the other half we use for sampling, and we call that a working half.
Yeah, so by archiving, we're leaving ourselves a resource, so if we need to come back to it in the future, or an opportunity just to observe what the stratigraphy was like. So although we take photos, it's often very useful to come back and actually look at sort of a real physical version of the core. But it also is there that in the future, if we come across something more interesting or maybe a new scientific technique is available, that we can go and we can get fresh sampled things if we've sort of depleted our working half.
Yeah, exactly. And these cores can be stored for hundreds of years. And there are cases where people request cores that have been stored and not looked at by a single person for 50, 60, 70 years. And can still be used to get data in the future. So the idea is that you keep material behind for any advances in technology and advances in scientific research, so that there is material and we don't have to go back and recollect in something that is quite an expensive and time-consuming process to collect these cores and this information that can be used for future work.
And what's really cool about using the ROV is that normally when you're coring, you don't always have this visual of what the seafloor looks like. But whilst we're doing it here, we have this all in film, albeit today not so clear. We can't exactly see everything that's going on, but those researchers who may want to use the cores in the future can not only look at the archive part, but they can also go back and look at the recorded footage. They can look at the conditions in which it was collected in, so it provides them with so much more information than we have otherwise going in sort of blind for something like gravity coring.
Exactly. So just going back to the screen now, so you can see the robotic arm is now is moving the vibrocore. So we've collected hopefully some material here, and we'll try and store this onto the base, where we have something called a core catcher that stops all of the material sliding out. This is then pushed into the base of the core, and at the top we'll just have our water surface that's recorded. So when we get this back to the lab, we essentially cut around until we find the top of this surface. We just put some foam at the top to make sure it's got a soft surface at the top, and we seal and cap it on both ends. So this is tightly packed in then as sediment on top and bottom.
This means it doesn't move around when we're transporting it, which enables us to move into the lab and put it horizontal, so we can't look at it whilst it's vertical. It will all fall out. But by having this foam, it means we really preserve those inner layers that we're trying to capture with the vibrocore.
Yeah. No, I mean the water is still quite murky, so we can't really see many biological things of note or interest. I think we're seeing some krill and maybe some small fish as well. I mean, this is a volcanologist talking. I've got a Juan Luca behind me, so I'm just asking him if you've seen anything. Seen anything interesting on there? Nada. Nothing. Yeah, so just lots of krill I can see on some of the cameras here.
I think we might have seen a fish earlier on, but I think we'll just have to wait and see until it clears a bit more.
Yeah, plenty more fish in the sea, I'm sure.
Yeah.
Seb's shaking his head.
Yeah. Yeah, so we thought we would talk about as well today. Seb mentioned we had 16 different schools come on board. We were involved in sort of giving the tours, showing them around.
Yeah, it was a really exciting day for everybody on board. You can spend many weeks at sea and not see anybody else for that entire time, not even another ship sometimes, depending on where you are. So it was really exciting to have so many people on board, and young children up to sort of teenager ages as well, which were just really enthusiastic about the science and just seeing this awesome ship really. So so we had many schools and their teachers as well, which I think was really thrilling experience for them as well. We first of all started off by bringing them into the lab and talking them through the process. Brought them into this ROV dive room, showed them all of the screens and monitors and everything that you guys can see at home, and spoke to them about the observations we see. And we have footage of this, which was shown to them as well. And then we showed everything that we worked through. So unfortunately, this is something that you guys can't see at home, but we'll talk about how these cores are then split, and we have these archive and working halves. So essentially, as soon as they're split, we photograph these cores just to document the fresh surface as soon as it's been split. If you leave this for time, then the surface can oxidize, so it gives a slightly different appearance, different colours as well that are at the surface. And then as soon as we photograph this, we move straight onto a description. So we describe everything that we see, very observational science, and we make some initial interpretations. So this is maybe around, we call them deciding facies, this is just a term for deciding different units or packages of material which look similar. So we occasionally, split this up based on grain size or based on colour, or any other kind of features that we can see. Some might have higher componentry of fossils, for example, or bivalve shells, compared to other layers which have got these completely absent. So we decide this on a number of factors, and sometimes we can't really see with our eyes as well between these. So we take little smear slides of these. This is where you take a little bit of material with a toothpick, you put it onto a slide, you dry it out, and you can then see under a microscope what these units contain. We've seen some really interesting units. We've seen really different colour changes and different types of material in here. We've seen different types of volcanic ash. We've seen some very dark ash deposits, and we've seen some very light ash deposits, which indicate different compositions of eruptions. So something that's a more sticky, more explosive eruption, compared to something that is more of an effusive and low-level volume eruption as well.
So for those watching as well, we've just got the first fibre core is back on the rack, and we're just going to take out the second one now.
Yeah, so the claw is just carefully moving the sort of stopper that stops falling out, and it will be precise enough to pick this up. So our ROV crew here are effectively using the sort of model arm of this to model it and recreate the movements, and this really sensitive control basically allows these really subtle movements. So I think we could pick up something like an egg or even smaller with these.
Yeah, they can pick up really tiny bits of sort of like coral to parts of sort of seaweed and other plant materials. They've got to be really gentle. Obviously, because these are aluminium tubes, they could be a little bit harder with them, but again, really delicate operation.
Mm-hmm. Yeah, the hands of heart surgeons. I don't think I really couldn't do this, to be honest. I'd be shaking all over the place.
And that's why you're sat back here.
Exactly.
No, so my part of the day was to show the visiting students and their teachers the geophysics lab. So sometimes we call that the hydroacoustics or the sonar. And what's involved in that is imaging the sea floor, the water column, so what's happening in the ocean, but also what's below the sea surface. We do that using sonar, so acoustic waves or sound waves. We do this because we can't use light waves. So what the ship is always emitting is a sound called a ping, and that travels right the way down to the seafloor and measures the depth of the water. So measuring the depth of the water is known as bathymetry, and by doing that we can build up a map of what the sea surface looks like. And then we use a slightly more intense sound to penetrate below the sea surface, and that reflects back off different types of materials, whether we've got mud, whether we've got sort of a harder rock, and that allows us to look at the stratigraphy or the layering of the rock below the sea surface. So this is not only important for sort of understanding what the area looks like just for us who are interested in the mapping side, but it's really sort of pivotal in choosing where we want to sample. We need to know what material might we be encountering, what's the depth of the water that we're working with, but then also understanding the water column. So we want to know what the current's doing, what's the temperature, what's the salinity. So we measure that whilst we're mapping. So we do that with CTDs. Which goes and measures the conductivity, temperature, and I think it's depth.
Yeah, and salinity as well.
Yeah, so that's conductivity.
Yeah.
So
Yeah.
how conductive the water depends on the salinity, so the brininess of it.
Yeah, sorry, I was just getting distracted by the cameras. Just for everybody watching at home, so we've just attached the vibrocore. It's just been attached now onto the actual core component of this, the core barrel. It's been attached to the vibrocore, and then, yeah, as you'll see in a bit, we'll have some vibrations. We'll test these vibrations, and then we'll have it at the right point where we can then push this down in terms of the sediment. So we'll give a bit more of a commentary as and when things happen. So a few more, maybe some smaller fish, still some krill. We've had some amazing wildlife and sea creatures. We had a really clear octopus that was just posing for the camera the other day, sitting right in front of the screen, and then as we got a little bit closer, it swam off, and it was an incredible view. We've seen some really other interesting creatures. I think it was.
Yeah, we've also been quite lucky. We've seen some sort of animals at the surface. So a few days ago, we saw some penguins, which I definitely wasn't expecting.
That was really cool.
But they live on some of the islands around here, so we often see them around the evenings, and we've been told that's because they're sort of heading back to the islands at the end of the day. I believe they're Humboldt penguins, but we've also seen a variety of different birds. I was very shocked to see pelicans. Wasn't expecting to see those.
A couple of our team managed to make it onto shore today as well. So managed to collect some deposits just along the beach and along some of the deltas that are on land. Picked up some really cool rocks as well for us to do some comparison studies. And they also saw some really interesting wildlife. I think they saw, just a kingfisher. I don't know if it's a South American kingfisher or I've forgotten the name for it, but it's much bigger than a European kingfisher, which we have back home. And unfortunately I didn't get to see it, but I saw a photo and it looked incredible. It's on my list of things to see.
So it looks like we've just kicked up quite a bit of sediment, so we're just waiting for that to sort of clear a bit more.
Yeah, let the dust settle. Seb's shaking his head again.
No, that was a good one.
Oh, another cloud. Oh, brilliant view.
Every cloud.
Silver linings.
Every cloud, yeah. So in The Simpsons, eat my dust. Sort of homeless.
I don't know.
It's been a while since I was in The Simpsons. In the UK, it always used to be on at 6 o'clock every weeknight.
Just as I got home from school.
My dad would always say, "Why don't you watch the news or something like that?" But just wanted to watch The Simpsons.
Yeah, so let's get back on topic. So whilst we had the schools visiting today as well, not only did they see the geophysics and the rock lab, but they also got to go to the wet lab. So this is where they're preparing a lot of the water samples, but also looking at the sort of really micro scale biodiversity, particularly looking at diatoms and forams, and they can be used to sort of interpret about the environment in which where the sediment was deposited. So we're looking not only at the surface, so what's living in there now, but what's living in there sort of in the past.
Mm-hmm.
And then they also got to visit the biology lab, so that's where they're looking at sort of the more macro scale fauna. So we've had some interesting ones. Yeah, we had a basket star. We've had a variety of different
mantis shrimp.
Mantis shrimps.
Yeah, that was pretty cool.
Some interesting
very powerful
looking
sting or punch or something. Yeah.
interesting
right?
looking worms.
Mantis shrimp, yes. I'm getting a thumbs up. I'm learning.
And then they also got to go and have a look at the ROV whilst it was on the surface, so you could get right up and close to it, have a look, see what it does, see what it's made of. But yeah, I think it's a really, really important learning experience for them, but for us as well. It's so interesting to get to talk to some of these students and teachers, the people who are living in the communities that was affected by this, but also are living there now.
And we had some music.
Yeah, we did.
Oh, yeah.
They prepared a performance for us with an accordion, a guitar, and some singing.
Yeah, so we have Danny on board, who's a teacher in a school in Chaiten. And yeah, her students were really, really happy to see her, and she got lots of hugs, I think, throughout the day. So
Yeah, I think they've been missing her.
yeah, definitely. And yeah, she taught one of the children. She taught the accordion, and she was playing the guitar, and yeah, so it had a small group of them that were singing, and then the song was really catchy. We had it in our heads all day and we're humming it, and we found out that it was actually a song that they'd actually composed themselves. So this isn't actually a song.
I didn't know that.
Yeah, composed it themselves. It was really catchy. So I think they've got an album in there somewhere. They need to go on. America's Got Talent or something. You know? But yeah, it was absolutely incredible. It was really good. So fortunately, it's still quite.
Want to give a rendition?
Go on, Alistair. I think you should do it. Yeah.
Seb was humming it earlier.
I've got the tune, just
Oh,
lost.
I think it's not the same.
The tune's good enough if you want to sing it to.
So we don't have to worry about a copyright strike.
That's true.
Yeah, did you say it was written about this?
Yeah, I didn't know that. Yeah.
That was incredible.
Go ahead and vibe.
Okay, so you can see now the vibracore is vibrating. It's pushing the barrel down in terms of sediment. So we have a whole bunch of screens here that record, the level of vibration, the resistance that we're getting as well. So this is all logged, and we can see and compare this as well to the sediments that we pull up, and actually, use this to inform our future dives and other target areas for things that we think might have been promising that weren't, or areas that we thought wouldn't be promising that have been. So a bit disjointed at the moment because I'm trying to hear with the other ear, see what the discussion is in front of me. So we're just down in terms of sediment, just vibrating again. Visibility is still quite low. Now we're raising the core barrel. It's just pulling up slowly. Hopefully packed full of goodies. And for us, hopefully packed full of volcanic material as well. As the diatoms and the microbiology is great, but yeah. The stuff that really excites the majority of the people who are in the room at the moment is the volcanic side of things. But yeah, we all work together as a collaborative team. Yeah, no area is more important than the other. So if we've got a ash layer or a volcanic layer, then yeah, using the stuff above and below that, using the shells and the shell fragments, this can inform us about sea temperatures at the time. It can inform us about impacts. We can even learn things about the impact of the volcanic eruption on the marine environment and the marine life, which is one of the key aims of this cruise. So collaboration is key. Yeah, we've got, I don't know how many different countries got represented on board.
Yeah, we've got researchers from across the globe. So obviously myself and Alistair from the UK along with Seb. But we also have some from Italy, Malta, New Zealand, obviously those from Chile as well.
Yeah, over half of our team is comprised of Chilean researchers, which is brilliant.
Yeah.
We even have a volcanologist from Senegal, who's the national, the geological survey of Chile.
Yeah, and they've just got such a wealth of knowledge that we're so lucky to have them on board. We could read papers, you can sort of look online, but to have that knowledge sort of at our fingertips is amazing.
Yeah. So these guys are in charge of all of these volcanoes, any alert level changes. They're in charge of producing hazard maps and leading on the evacuations as well. So that's informing CENIPRED, which is a civil protection of Chile. So if they note anything in the science, and they'll have an emergency meeting with CENIPRED, and then governmental decisions or municipality level decisions will take place. So they quite rightly so, I think they try to have a presence in many of these communities and to gain trust with local people. And it's a kind of two-way symbiotic relationship, exchange really between between the public and the authorities in this case, where, like we were saying earlier, the local people who are on board today and people who live around these volcanoes know these volcanoes better than anybody else, better than any scientist really. They notice any subtle change in the volcano or the crops or anything that is surrounding that environment, and this knowledge is really, really invaluable really to scientists to then marry up and compare with the scientific data which we can quantify and we can measure, and understand a lot more about.
Yeah, so what we're looking at here is, I think we did lose the top, so the valve of the core. You can just about see it lying on the seafloor just in sort of in front of the vibrocore. I believe we went ahead anyway, which would be interesting. It would be interesting to see what happens, see what we bring up. Never know, it may change our coring technique for future dives.
Yeah, and we've got Sion and Jacob here as well, just looking over at them, smiling away, putting their thumbs up,
Yeah.
saying hi.
Hello.
Hello, there we go. So, yeah, so these are really crucial roles that these guys are doing at the moment. So it's a recording. We have something called Sea Log, where we record everything electronically in terms of what's happening during this dive. We also have handwritten notes as well. These handwritten notes are the best in my opinion. Anything can go wrong with computers and technology.
Yeah.
But
The only problem is Alistair has teeny tiny handwriting. Makes it a real pain to read when you're reading through his logs.
yeah, I do. I do it in block capitals, so it's hopefully a bit easier to see.
No, I think it makes it worse.
Okay, I'll take this constructive criticism forward. Probably not change it.
No.
Yeah, it's still
Do you know
quite
who-
murky, isn't
yeah.
it? Yeah, sorry.
I was going to say, do you know who has really bad handwriting? Seb.
Dr. Sebastian Watt, yeah.
What's that?
Terrible handwriting.
Terrible handwriting.
Yeah. He's got the handwriting of a medical doctor.
He is also left-handed, so when he writes on a whiteboard, he rubs it out as he goes.
Yeah.
Have to be quick. Be watching carefully. Criticisms?
I'll have a think.
Not for now.
I say come back to me.
Yeah. Make a list.
Good, that's out. Okay, thanks guys. Thanks Alison. That was great.
So I hope
We've been
everyone
cut
enjoyed.
Yeah.
Not at all. You said
No,
you'd finished.
well, no, we're still here.
Feel free to chip in. This can be a three-way chat.
Okay.
Right, so we just had that second vibrocore go in. They both went in very easily, although met a bit of resistance at the bottom, which I'm hopeful about. We'll see. We'll see when these come back on deck what we find. We took some crab samples here yesterday, as I said, and we from the geophysical data, it looks like there's a thick unit which is transparent in the hydroacoustic data, which means we'd expect it to be sandy and structureless, and we got crabs full of mud, which potentially means there's a large amount of mud accumulating over a very short time period, if this is since the eruption, which is a little surprising. But then the eruption completely changed this river system. It inundated the sort of the drainage basin that I guess was in sort of a more of an equilibrium before the event. So it changed the routing of the river. It would have deposited a lot of material that could have changed runoff. So it's perfectly plausible that the patterns and rates of sedimentation changed quite dramatically after the eruption. And indeed, that's something that we potentially will be able to find evidence of when we get some dating on these samples. So it may indeed be an important part of the story here. Another impact, if you like, of this volcanic eruption in terms of affecting runoff from the land and the rates of sedimentation in the adjacent ocean. So we'll have to see, but this is one reason why we're aiming to take this vibrocore here, so we can recover, aim to recover material beneath this what we think is this sort of covering of mud. So we'll have to see when this comes back on deck, but the fact we've got two vibrocores is promising because it means we can open one on board. As I've said on some previous dives, we leave the other one archived so that we can then look at it in the lab under sort of more controlled conditions. We can actually do a lot on the ship. We've got a really good setup. for various types of imaging and data and sort of careful visual logging. But, yeah, I think we ooh.
Just dropping things.
We're at the time. Did you recover that?
Just seeing some,
I think the push call's not really viable.
I
right?
wanted to see penguins as well.
You can't see.
Yeah, they were very,
No,
very
in
far
my
away.
case, I think, yeah.
Do you can clearly see them. Don't have
Yeah.
good photos.
Someone asking about penguins, are they? I hadn't seen that. Where's that?
Bridge, ROV.
Jason in Michigan.
ROV Bridge.
Penguins, yes, yeah. I missed them. I didn't see
Up
them.
on, thank you.
I think they come in, someone was saying they come in the evening, and so you just, if you're lucky, you see them bobbing up and then they dive down again. Humboldt penguins, I think they are.
Yeah, that's what Gary said.
Yeah, all right. Sorry, I'm obviously repeating what you've already told
It's like
everyone.
it's a parrot in the room.
Or a penguin even. Right, so the visibility is so poor that we can't actually do any of our other types of sampling. So previous dives you might have seen us collecting these short push cores, which preserves the seafloor interface. And you may have seen us collecting these scoop bags. But there's two reasons that's not been possible on this dive. One being the visibility and the other being the time. So it was sort of limited in terms of time. We're pretty near shore here. It's getting late in the day in southern Chile. So we're still very near Chaiten town. If we look out the window on the ship, I guess it's, probably not much more than a mile away. So we're going to bring this back on board, and then we'll be continuing that mapping overnight. And we will be back in the area tomorrow, hoping to do a couple more ROV dives, slightly further offshore, to sort of complete the map, if you like, in terms of where we've done these dives, and hopefully build a picture that will allow us, provided with enough information, to produce a sound interpretation of the region. It's always tricky with the ROV dives because although you know 5-10 dives sounds a lot, when this is done over that many hundreds of square kilometres, it's a few pins in the map, and so we need to use the geophysical data to really carefully plan that and to connect these dots. So we'll see what we get tomorrow, but we will be back here in the morning. So a lot of sediment being kicked up on our way up. That gives you an indication of how soft this material was. The ROV really sort of sunk down when it hit the seabed, and we can see these sort of piles of muddy sediment on all the base of the ROV. I guess in some ways that does the job of our scoop bag sampling. It's probably not intact enough for the biologists to use.
We try and take more than 1 record as well, so we don't put all of our eggs in one basket. So, yes, we can try and...
Yeah. Do you want me to?
Yeah,
okay.
Just for archive.
Sorry, Lester, to interrupt you. Anything else you wanted to add before we close off this dive? No? All right, okay. Sorry for the slightly abrupt finish there. We're on our way back up, and we're going to end the live stream there. So thanks for those who joined us today. It was quite a short one, but we appreciate everyone tuning into this. And as I say, we hope to be back tomorrow, so we'll hope to see you then.
Hey,
Thanks
that's
again.
loud and clear.